This is Mrs. Sharp, and I'm going to go over 2-9 with you. The reason you are watching this on video as opposed to me going over it in class with you is because a lot of you know this already, as was evidenced by your pretest. So if you're watching this, hopefully that means either you just wanted a refresher or you feel pretty clueless on scientific notation, or you just want to make sure you're doing it right. But here we go. This is 2-9. Your goal is to express numbers in scientific notation and to calculate numbers in scientific notation. So scientific notation is a shorthand expression for writing really big or really small numbers. It's a convenience thing. To write out a really large number takes a lot of zeros and a lot of time, so we can avoid all that time by using scientific notation instead. It is a product of two factors or two numbers. The first factor is always a coefficient between 1 and 10. So that's the name. It's a coefficient. Always has to be between 1 and 10. And the second factor is a power of 10. So it's always written with only one number to the left of the decimal point. That goes with this first factor. So what you'll look at is something times 10 to the something. This number right here is your coefficient. And that is the number that needs to be between 1 and 10. This number is a power of 10. If it's a positive number, it means multiply by 10 that many times. If it's a negative number, it means divide by 10 that many times. So let's keep going here. All right, this is what we just talked about. If we wanted to know the number of carbon atoms in the Hope diamond, there's a picture of the Hope diamond. Isn't it pretty? It is 4.6 times 10 to the 23rd carbon atoms. That means you're going to take 4.6 and you're going to multiply it by 10 23 times. So this is a huge number. Whoa! So you can see how you're going to save yourself a lot of time and energy if we can write it this way instead. Now, a lot of my students get confused when they're doing this. This number and this number mean the same thing. They mean exactly the same thing. We're just writing it in a different way. The mass of one carbon atom, you would imagine that that would be really small. So here's this number, 2 times 10 to the negative 23. Well, that means I'm going to divide 2 by 10 23 times. So if I do that, I do get a very, very small number, but look how much more convenient it is to write it this way instead of 0, 0, 0. How many zeros are there? I don't know. So again, they mean the same thing. These two numbers are exactly the same. They mean the same thing. They are equal to each other. This is just a different way of writing it. So that negative means we're going to divide by 10 that many times. So negative 23 divided by 10 23 times. Or you can think of it as moving your decimal to the left 23 times. Each time being one division by 10. Okay. I would like to give you one more example here before we leave. So I guess I'm going to do this here. And we'll ignore it. I just need some blank space. So we're not really doing 210 right now. We're still doing 29. Let's say I had this number, 4,397. Oh, let's make it even bigger, 111. 4,397,111. And I wanted to write that in scientific notation. Remember, that's a number times 10 to a number. This first number is your coefficient. That has to be a number between 1 and 10. So what you want to do is put your decimal place somewhere in here that makes a number between 1 and 10. So the only way I can do that is to put my decimal point right here, which would make it 4.397111. So we want to keep all the same numbers that we have here. We just want to write it as a number between 1 and 10. Well, right now, 4.397111 is not the same as 4,397,111. That's like way smaller. So we're going to use this part over here to make it so that these two sets are the same. So how many times would I have to multiply 4.397111 by 10 to get this number? Well, I'd have to multiply it 1, 2, 3, 4, 5, 6. So that becomes 4.39711 times 10 to the 6. They mean the same thing. This one is in scientific notation. Let's try another one. Let's say I have a really itty bitty number, 0, 0, 0, 4, 6. And I want to write that in scientific notation. So it's got to be a number times 10 to a number. First one has to be between 1 and 10. So I'm going to find how I can do that. On here, I got to make it, 4.6. Well, 4.6 is a lot bigger than 0.00046. So I have to use this part to reflect that it's not 4.6, it's really 0.0046. So in this case, to make it smaller, I'm going to have to divide by 10 to make it smaller. So this is going to be a negative exponent. So I'm going to move it over 1, 2, 3, 4. That means I'm dividing by 10 4 times to get this original number. So these two things mean the same. They're the same quantity, they just are in a different format. So that's scientific notation. I hope that helps get you started on some of those practice problems. I will see you later.